permanent long-term storage site within the brain, and therefore protecting them, making them safe. And it is important that we understand what during sleep actually transacts these memory benefits, because there are real medical and societal implications. And let me just tell you about one area that we've moved this work out into clinically, which is the context of aging and dementia. Because it's, of course, no secret that as we get older, our learning and memory abilities begin to fade and decline. But what we've also discovered is that a physiological signature of aging is that your sleep gets worse. Especially that deep quality of sleep that I was just discussing. And only last year we finally published evidence that these two things, they're not simply co-occurring, they are significantly interrelated. Especially suggests that the disruption of deep sleep is an underappreciated factor that is contributing to cognitive decline or memory decline in aging, and most recently we've discovered in Alzheimer's disease as well. Now, I know this is remarkably depressing news. It's in the mail, it's coming at you, but there's a potential silver lining. Unlike many of the other factors that we know are associated with aging, for example, changes in the physical structure of the brain, that's fiendishly difficult to treat. But that sleep is a missing piece in the explanatory puzzle of aging and Alzheimer's is exciting because we may be able to do something about it. And one way that we are approaching this at my sleep center is not by using sleeping pills, by the way. Unfortunately, they are blunt instruments that do not produce naturalistic sleep. Instead, we're actually developing a method based on this. It's called direct current brain stimulation. You insert amount of voltage into the brain, so small you typically don't feel it, but it has a measurable impact. Now, if you apply this stimulation during sleep in young, healthy adults, as if you're sort of singing in time with those deep sleep brainwaves, not only can you amplify the size of those deep sleep brainwaves, but in doing so, we can almost double the amount of memory benefit that you get from sleep. The question now is whether we can translate this same affordable, potentially portable piece of technology into older adults and those with dementia. Can we restore back some healthy quality of deep sleep, and in doing so, can we salvage aspects of their learning and memory function? That is my real hope now. That's one of our moonshot goals, as it were. So that's an example of sleep for your brain, but sleep is just as essential for your body. We've already spoken about sleep loss and your reproductive system. Or I could tell you about sleep loss and your cardiovascular system, and that all it takes is 1 hour. Because there is a global experiment performed on 1.6 billion people across 70 countries twice a year, and it's called daylight savings time. Now, in the spring, when we lose 1 hour of sleep, we see a subsequent 24% increase in heart attacks that following day. In the autumn, when we gain an hour of sleep, we see a 21% reduction in heart attacks. Isn't that incredible? And you see exactly the same profile for car crashes, road traffic accidents, even suicide rates. But as a deeper dive, I want to focus on this: sleep loss and your immune system. And here I'll introduce these delightful blue elements in the image. They are called natural killer cells. And you can think of natural killer cells almost like the Secret Service agents of your immune system. They are very good at identifying dangerous, unwanted elements and eliminating them. In fact, what they're doing here is destroying a cancerous tumor mass. So what you wish for is a virile set of these immune assassins at all times. And tragically, that's what you don't have if you're not sleeping enough. So here in this experiment, you're not going to have your sleep deprived for an entire night. You're simply going to have your sleep restricted to 4 hours for one single night. And then we're going to look to see what's the percent reduction in immune cell activity that you suffer. And it's not small, it's not 10%, it's not 20%. There was a 70% drop in natural killer cell activity. That's a concerning state of immune deficiency. And you could perhaps understand why we're now finding significant links between short sleep duration and your risk for the development of numerous forms of cancer. Currently, that list includes cancer of the bowel, cancer of the prostate, and cancer of the breast. In fact, the link between a lack of sleep and cancer is now so strong that the World Health Organization has classified any form of nighttime shift work as a probable carcinogen because of a disruption of your sleep-wake rhythms. So you may have heard of that old maxim that you can sleep when you're dead. Well, I'm being quite serious now. It is mortally unwise advice. We know this from epidemiological studies across millions of individuals. There's a simple truth. The shorter your sleep, the shorter your life. Short sleep predicts all-cause mortality. And if increasing your risk for the development of cancer or even Alzheimer's disease were not sufficiently disquieting, we have since discovered that a lack of sleep will even erode the very fabric of biological life itself, your DNA genetic code. So here in this study, they took a group of healthy adults and they limited them to 6 hours of sleep a night